Hello children, welcome to mathematics online classes children. So today from mathematics subject quadratic equations chapter we are going to learn. So here children, in this video the contents we are going to cover are some of the basic concepts we are going to cover. After that, how to find value of a quadratic polynomial, how to find zeros of a quadratic polynomial, and about quadratic equation and about its roots, and solving a quadratic equation by factorization method or by completing the squares method or by using quadratic formula. In this way, the solving of a quadratic equation by different methods we are going to learn in this chapter. One is by factorization, another one is by completing the squares method, third one is using the quadratic formula. And one more thing, nature and character of the roots of quadratic equation, that also we are going to learn. And about sum and product of roots, how to construct a quadratic equation whose roots are given, or how to reduce quadratic equation, or problems based on different quadratic equations. All these concepts we are going to learn in this chapter. So let's start the one by one concepts. So basic concepts. You are all aware that algebraic polynomial of second degree is called a quadratic polynomial. So polynomial means the expression having many terms. The expression having many terms is called as a polynomial. In the polynomial, these are all polynomials. This first expression, second one, third one, fourth one, these are all polynomials. In these polynomials, if you observe the first example here, the power of the first term is 2 and the power of second term is x power 1 and the power of third term is x power 0. Means here the powers for the variable x are 2, 1, 0. Out of these three, the highest power is 2, which is called degree of the expression. The highest power of the expression is called degree of the expression. In this first example, as the degree is 2, it is considered as second degree expression. So these type of second degree expressions are considered as quadratic polynomials. So what is a quadratic polynomial children? A polynomials means an expression having many terms. So an expression having many terms, if its degree is 2 or if its highest power is 2, it is considered as second degree equation, and it is also considered as quadratic polynomial. So this is the basic concept. In second example, 8x square, power is 2 here, 6x, power is 1 here. There is no constant term, plus 0 we can keep. 0 into x power 0 we can keep, where power is 0. Here the powers are 2, 1, 0. Highest power is 2. So this is also an example of second degree expression, which is also called as quadratic polynomial. If you see here, third one, 5x square minus 7. Highest power is 2. Root 2x square. No need to bother about the coefficients. They may be root numbers or anything else. No need to bother about them. So just here the power is 2, highest power is 2. So that's why it is called as a quadratic polynomial. So this is the basic definition for a quadratic polynomial children. So you have to remember two things. Highest power should be 2. Then it is called second degree expression, or it is also called quadratic polynomial. Next. So the one which So here, the general form of a quadratic polynomial is ax square plus bx plus c. So generally, we write in the form of ax square plus bx plus c. Means x square term, x term, constant term, where a is the coefficient of x square term, b is the coefficient of x term, c is the constant term. So where this a, b, c are real numbers. A, B, C are real numbers. And one more condition, a should not be equal to 0. A should not be equal to 0 and x should be the variable. X should be the variable. Because in ax square plus bx plus c, if you take a as 0, then it will become 0 into x square plus bx plus c. 0 into x square, it will become 0. Only bx plus c will remain. Highest power will be 1, which is a first degree expression. So which is not a quadratic polynomial. So the condition is, the general form is ax square plus bx plus c, where a, b, c are real numbers and a should not be equal to 0 and x should be variable. This is the general form. So here a, b, c are constants. A, B, C are real numbers, or we can call them as constants. So A, B, C are also called as real constants. That's why we call them as real constants. So if you observe here, 3x square minus 5x plus 8. We have real constant 3 here, minus 5 here, 8 here. This 3 minus 5, 8 are constants, or real constants, and x is the variable. X is the variable. You might be getting questions like this, children. So write the general form of quadratic polynomial means you have to write ax square plus bx plus c. And the condition, a comma b comma c should belongs to real numbers and a should not be equal to 0. This is the condition. Next one. So value of a quadratic polynomial. Value of a quadratic polynomial. So here we are telling the general form of quadratic polynomial is ax square plus bx plus c, where a, b, c, where a comma b comma c are real constants. Constants means whose value already known. Whose value already known. No need to find the value of constants again. They are called as constants because their value is already known, which is a constant, which won't change. So which value we have to find here? We have the variable x. Variable means whose value varies depending on the given conditions. So here x is the variable, so we have to find the value of the variable. Suppose if anybody asks you to solve the quadratic equation, solving of quadratic equation is nothing but finding the value of the variable. So here the concept is how to find the value of a quadratic polynomial, which is in the form of ax square plus bx plus c. Suppose if you want to find ax square plus bx plus c value at x equal to alpha, what is the value of polynomial when the variable equal to alpha? So then here what we have to do means in the x place we have to keep alpha, because x value we have to find at alpha. Sorry, x value is given at alpha, so we have to find the value of quadratic polynomial when x equal to alpha. Here children, we are finding the value of polynomial, not value of variable. Value of variable is different. Value of variable means value of x. Value of x or solving quadratic polynomial. That concept is different, children. Here we are finding value of quadratic polynomial when the variable equals to certain value. Then what is the value of polynomial? That we are learning here. So when x equal to alpha, what is the value of ax square plus bx plus c? Just we have to keep in the place of x alpha, a alpha square b into alpha plus c, or a alpha square plus b alpha plus c is the value of the quadratic polynomial. Value of the quadratic polynomial. Suppose if x value at beta, what we have to do? Just we have to keep in the place of x beta, a beta square b into beta plus c. So a beta square plus b beta plus c is the value of the quadratic polynomial. Suppose if x equal to 5, so then the equation is ax square plus bx plus c, a into 5 square b into 5 plus c, a into 5 square 25a plus 5b plus c, 5b plus c. Like that also we can find. Or we have to find the value of 5x square minus 3x plus 4 when x equal to 2. Just we have to keep in the place of x 2, we have to keep 5 into 2 square minus 3 into 2 plus 4. 2 square is 4, 4 into 5 20, minus 3 into 2 6 plus 4. So 20 plus 4, 24, minus 6 equal to 18. Like that, when x equal to 2, the value of quadratic polynomial is 18. Like that, we can find the value of quadratic polynomial when variable value is given. That is one concept. So here, in second example, value of x square minus 8x minus 15 when x equal to minus 1. When x equal to minus 1. In the place of x, we have to keep minus 1. Minus 1 whole square minus 8 into minus 1 minus 15. Minus 1 whole square means minus 1 into minus 1. It will become plus 1. No need to mention plus. Minus into minus plus 8 1 is 8 minus 15. 1 plus 8 9 minus 15. 9 minus 15 means minus 6. Minus 6 is the answer. Or we have to find the value of polynomial 7x square minus 4 at x equal to 2 by 3. At x equal to 2 by 3. 7 into, in the place of x, 2 by 3 whole square minus 4. 7 into 2 square means 4. 3 square means 9 minus 4. 7 into 4, 28 by 9 minus 4. We have to take the LCM. LCM is 9. 9 1 is 9. 1 in 28, 28. Here there is nothing. So directly we have to multiply. 9 4 times 36. So minus 36 plus 28. So minus 8 by 9. Value of the polynomial is minus 8 by 9. Like this, we can find value of any quadratic polynomial given the variable value. Next challenge. Here, next concept is zeros of a quadratic polynomial. Zeros of a quadratic polynomial. Suppose we have a polynomial x square minus 7x plus 10. This is the polynomial. For this polynomial, zeros we have to find. Zeros we have to find. At x equal to 1, if we substitute the values, we are getting the answer 4. At x equal to 2, if we substitute the values, we are getting the value 0. At x equal to 3, if we substitute the values, we are getting minus 2. At x equal to 5, when we are substituting the values, we are getting answer 0. 0. So here means for some values of the variables, the value is not equal to 0, but for some values of the variables, values are equal to 0. Equal to 0 means the value of variable for which the quadratic polynomial is becoming 0, that values of the variables are called zeros of the given polynomial. They will differ from polynomial to polynomial. For all the polynomials, we cannot have same zeros. So different polynomials will be having different zeros. It means, so for this given expression, we have observed that the given expression is 7x square minus 7x plus 10. We have observed that at x equal to 2 and at x equal to 5, the value of this quadratic polynomial is becoming 0. So this x equal to 2 and x equal to 5 are called zeros of the given polynomial. Zeros of the given polynomial means if x equal to alpha, for x equal to alpha, if the polynomial ax square plus bx plus c becomes 0, when we keep x equal to alpha, then 0 of this given polynomial is x equal to alpha. Means the value of variable which makes the quadratic polynomial 0, that is called 0 of the quadratic polynomial. 0 of the quadratic polynomial. Next, we have some examples here. Example 1, show that x equal to 3 is 0 of quadratic polynomial x square minus 2x minus 3. Or x equal to minus 2 is 0 of this polynomial. X equal to 4 is not a 0 of this polynomial. If you see the first example, we have to show x equal to 3 is the 0 of x square minus 2x minus 3. Just what we will do, we will substitute in the place of x 3. 3 square minus 2 into 3 minus 3. 3 square is 9, minus 2 into 3 is 6, minus 3. 9 minus 9 equal to 0. Means when x equal to 3, the polynomial is becoming 0. So x equal to 3 is 0 of quadratic polynomial. Like that we can confirm. In example 2, this is the expression. We have to check x equal to minus 2, whether it is 0 or not. In the place of x, minus 2 square. In the place of x, minus 2 plus 2. 3 into minus 2 whole square. Here we will get minus 4. Minus 4 into 3. Sorry, plus 4. Plus 4 into 3, 12. 7 into minus 2, minus 14. Plus 2 equal to 0. 12 plus 2, 14. Minus 14, 0. Yes, it is the 0 of quadratic polynomial. Next, another one. Value of this at x equal to 4. Let's substitute 4 here. 2 into 4 square. 7 into 4. Minus 5. 4 square is 8. 8 into 2, 32. 7 into 4, minus 28. Minus 5. Minus 28 minus 5. 32 minus 33, which is equal to minus 1, which is not equal to 0. So this is not a 0 of a quadratic polynomial. Like that, we can confirm, children. Next, another example. Find the value of m if x equal to 2 is a 0 of quadratic polynomial, this polynomial. We have a quadratic polynomial 3x square minus mx plus 4, where m is a constant whose value is unknown. For finding this unknown m value, they have given a clue that x equal to 2 is the 0 of the given polynomial. So what we can do, in the place of x, we can keep 2. 3 into 3x square means 3 into 2 square, minus mx means minus m into 2, plus 4 as it is. But as x equal to 2 is the 0 of polynomial, when we substitute x equal to 2, this entire expression will be equal to 0. We can equate to 0. So 2 square means 4. 4 into 3, 12. Minus m into 2, minus 2m. Plus 4 equal to 0. 12 plus 4, 16 minus 2m equal to 0. Or 16 equal to 2m. Or 2m equal to 16. M equal to 16 by 2, which is equal to 8. Like that, if the 0 is given, then any unknown term present in the polynomial, that also we can find out. So this is all for today, children. So what we have learned today from quadratic equations chapter, we have learned the basic concept, and we have learned the concept of finding the value of quadratic polynomial, how to find 0 of quadratic polynomial. These concepts we have covered, children. So here, basic concept we have covered, value of quadratic polynomial we have covered, zeros of quadratic polynomial. So these three concepts we have covered. So let's revise the remaining videos in our next video, children. So thank you for watching our video, children. So have a good day.